¿Ven las transparencias? Sí. Vale, fantástico. Okay, so hi everyone. So welcome to the Galaxy and Cosmology session. So in our group, we have received 78 contributions in this topic, and we have split it in 3 themes. One is the local universe, which will be covered by Anna later. High redshift universe and cosmology, which will be covered by Fernando. And I will take care of the multi-wavelength results and AGNs. Okay, so first starting with ALMA radio results. So Bellocchi presented a contribution on studying luminous infrared galaxies, and he shows maps of molecular gas mass versus dust temperature at sub-kiloparsec scales, and you can see an example here. So very detailed maps and studies. We also had 2 contributions on superstar clusters, which are young stellar clusters of large mass. One from Enrico Villas, who's tracing emission lines to trace a recent star formation. Here you can see an example of NGC 3110, where he found that the SSCs are mainly in the center of the galaxy. We also have an SSC study from Jimenez in the M82 galaxy. And in this case, most SSCs are still forming. Okay, we also got 2 radio surveys presented, one from Jimenez on the vertical program with ALMA, where he's tracing as carbon monoxide in 51 spiral galaxies of the Virgo cluster to study the influence of the environment in galaxy evolution. Also, the low-fire sky survey was presented by Sabater, which is the deepest low-frequency northern sky survey to date. It can resolve many more sources than previous surveys extending into a larger field of view. And a special issue in NAA is in preparation to discuss this survey. From Nancy, we got a detailed study on transients in the luminosity gap between the supernova and the nova in this region, which is less studied. And the goal of this study in the long term is to understand the progenitor nature of these objects. From Hernandez Garcia, we got a study on giant radio galaxies, which are AGNs with extended radio emission. And it identifies the AGN with restarted activity, looking for a peaked gigahertz emission. Okay, so now moving to high energies. So recently, last year, it was published in Nature a new phenomena, which are the X-ray quasi-periodic eruptions, which is a novel extragalactic phenomena associated with accreting supermassive black holes. And Giustini, in his contribution, presented a second observation of this phenomena using XIV Newton data. So it's not something by chance, but it seems to be a real phenomena. We also got a contribution from the gamma ray community on dark matter's annihilation searches using dwarf spheroidal galaxies, which are ideal candidates as they have a very large dark matter content with low astrophysical background. And so limits on the annihilation cross-section of dark matter versus dark matter masses obtained. And you can see the limit is below the relic cross-section between 10 and 100 GeV. So this region of dark matter masses is pretty much excluded. Jorge has presented a long-term program of optical follow-up of gamma ray blazars. And he has looked at both the flat spectrum radio quasars and BLX, and has seen that the optical flux shows some periodicity of the order of a few years. From Ramos Buades, we got a study on the effect of eccentricity in the searches with gravitational waves or binary black holes. And he has seen, even with very large eccentricities, the sensitivity is not much affected. And he tested 2 different LIGO models for black hole binary searches. So now moving to active galactic nuclei, here's where we have most contributions. So we have one study from Bellocchi on studying carbon monoxide spatial studies at different scales to trace the thermal structure of the AGN. And in the galaxy studied, NGC 4945, it was observed that the mechanical heating is the dominant mechanism. From Barquín González, we've got a study on the fraction of sky obscured in the AGN, the dusty torus, for different AGN classes, the type 1 and type 2, and also subclasses. And he could find some, oh, he or she, sorry, I don't remember, could find some similarities of the lower types. The type 1.8 and 1.9 was different and different to the standard type 2 AGNs. From Barquín González, we also got a study on AGN with jets. So the goal of the study will be to study the effect of the relativistic jets of AGNs on the wind and the structure of the emitting region. They have 36 quasars in the main sequence in hand, and currently they're analyzing the ultraviolet data. From the low luminosity AGNs, we have 3 studies which were presented by these 2 ladies, Hermosa, Muñoz, and Cazzoli. So we got first a spectroscopy study of these low luminosity liners to distinguish the broadland region and the outflows of AGNs. Also a second contribution studying the morphologies of these outflows. And finally, a very detailed study of NGC 1052 with high resolution, both spatial and spectral, using Muse and Megara. And they concluded that there is a large kiloparsec scale rotating disk in this AGN. And the final contribution on AGN that was presented was from Moral Castro, asking the question, are active galaxies more rotationally supported than normal galaxies? So they selected a sample of isolated twin galaxies with different nuclear activity. And looking at the spin parameter, they concluded that yes, in 80% of the cases, AGNs seem to be more rotationally supported. So now, after this express summary, I would like to conclude saying that we have a lot of multi-wavelength data in hand. We also are studying multi-messenger astronomy with gravitational waves and neutrinos. And so we need to combine all this new information to better understand the universe. And with this, I conclude, and I let Anna continue. Let me
Perfect. Thank you. I'm going to start sharing. Continue. Okay. Share. Perfect. So do you all see my slides?
Yes.
Yeah, perfect. Okay, so yeah, we're now going to move into the nearby universe. And the first thing that comes into mind is something like these beautiful galaxies and so on. But in order to first understand how these galaxies form and evolve, we need to understand more fundamental stuff. For example, the initial mass function. So we have a couple of works on that. The first one is by Lorenzo, that they study with Osiris a sample of OB stars in metal-poor galaxies, finding that the regions that have star formation enhancement, they have flatter IMFs. But the IMF evolves. So there's this code from Jerabkova that it's called GAL-IMF, that what it does is study this intergalactic IMF and shows these variations. So this is very important before we can understand how galaxies and their properties are. So the first talk or contribution on types of galaxies, there's this work from TOES where they study a large sample of lenticular galaxies. And basically they find that the majority of them, 3/4, are all in the passive sequence. Another type of very controversial galaxies are the ultra-diffuse galaxies. But once they are used or like computed the sizes with this more physically motivated size, R1, then they become at the size of dwarfs and they follow the scaling relations. But galaxies mostly we can shape them through different interactions and their mergers. So there's all these works that have focused on this. So Liesenfeld works with studying pairs of galaxies at different interacting phases. And they find that those that are in spiral pairs have the most enhanced star formation. And actually in this one from Diaz Garcia, they find that for the for the starburst galaxies in mergers, they also have an enhancement on their star formation. Grajales Medina here shows not 2, but 3 galaxies that are interacting. And actually through the star formation history, they have found out that this is an ongoing merger and they are studying it currently. And this one from Jones, they present FAIR, that it's let's say, findable, accessible, interoperable, and reusable workflow. I have to rate it, which is something that we should be using nowadays. So using this code, they study the neutral gas in a compact group. So how galaxies, spiral galaxies form their arms and bars, it's clearly one of the most controversial topics because we have a bunch of contribution on this. So the first one, for example, from Beckman is showing that the resonance pattern in disks of spirals is two-dimensional. Whereas here with Lara explains that the formation of the Large Magellanic Cloud spiral arm through looking at the different star formation histories in the two type of arms. Garcia sees that the bar strength correlates very strongly with the inner ring formation, and also in another work, they show that there are three distinctive modes on how the ionized gas distributes along within the bars. And finally, we have here a simulation work where Padura are testing on how to create the spiral arms, triggering or not by invariant manifolds. But what is clear is that in the recent years, there's been a boom in integral field unit studies. So I'm going to start with a few of them. So we have these ones from Timer, the collaboration. So this one from Lorenzo Cáceres is presenting the first detection of a peanut structure in the inner bar of a double bar system, which was one of the first times. Whereas Rosado Belza is presenting the stellar populations and kinematics of Timer galaxies that have nuclear rings. With Megara, we have a couple of works too. This one from Cazzoli, where they are studying that there are different, let's say, there are different disks situated at different scales in this galaxy NGC 7469. While in this one of Carrick, they study metal poor but highly ionized H2 region, and they put it as a candidate of being an analog of the early universe star-forming galaxies. Then with ALMA, combination of ALMA and HST, sorry, Sanchez Garcia look at the star formation rate in NGC 4068, and they show two different dynamical environments for the ring. Still with the gas, we have some works in Khalifa. So here, Rodriguez Varas is showing that the inner and the outer parts of the H2 regions have clear difference in their stellar populations. And in fact, Espinosa Ponce shows that there's a strong correlation between the ages and the metallicities, and they use the largest sample of H2 regions. Using the same sample, Valerdi are now studying the helium abundances in these ones and seeing if there are any gradients in this abundance. But usually one of the main keys of being in these surveys or doing them is so we can do one of our favorite tools, that it's finding scaling relations, no, or analyzing scaling relations. So in this work of Mendez Abreu, for example, they, besides presenting a new spectrophotometric decomposition code, they study the stellar populations and the mass growth of both bulges and disks in the Khalifa sample. And then here, Alvarez Hurtado, what they do is they study the mass metallicity relation for Khalifa galaxies, but they show that the form of this relation, it depends on the statistical criteria. And this can generate secondary relations that they don't actually exist. So be careful with that. Also with the mass metallicity relation, but now for the nuclear regions of galaxies, we have this work from Perez, where they are presenting this new code that I don't want to repeat the name because I don't want to mess it, but it's right here on the top. And then we have a couple of two works that they discuss on the bimodality between passive and active galaxies. Well, in fact, the first one, this one from Corcho Caballero and the collaborators, they claim that there's no such bimodality, that what it is just a single distribution with shallow power law tails. In this other one of Anzoco, using Sloan data, what they do is characterize in a novel technique Green Valley galaxies using the D4000, because this one is resilient to dust effects. A couple of works on the JPath survey. This work from Rodriguez Martin, what they do is they study this cluster 1001, and they do the stellar populations. For example, they see that the reddest galaxies, they are all closer to the center through the BCG. And in this other one from Martinez Solaeche, what they present is a new method called artificial neural network that does everything like in automated way. So they are now studying the luminosity function of J-pass galaxies using it. But all these relationships, they have been mostly with the stellar mass of the galaxies. But there's also a very important other property, that is the halo mass. So in this work here from Martin Navarro, what they are doing is showing that the halos of more massive black holes, for example, have more number of quiescent satellites and show hotter intercluster medium. And finally, with the Sea Eagle simulations, Alonso Asensio uses this method to calculate the halo mass and the mass density directly from the intracluster stellar mass. And a more technical one, we have this final slide that presents a set of tools that will open, in my opinion, new frontiers on how to do all these type of studies. So for example, we have these ones from Eftekari that presents a new set of near-infrared spectral indices. So this is going to be really useful for galaxy evolution studies. And the same for this one from Rodriguez Beltran that presents the method of studying the surface brightness fluctuation. That, for example, can reveal the hidden, metal poor component in very metal-rich L-type galaxies. Fernando is going to talk a little bit more about this type of studies in a second. And the last one is from Miljan Irigoyen, that presents, has two works. One presents a multi-phase code for galactic chemical evolution for galaxies with metals and dust. And the other one is an updated version of the code PopStar, but with Python. So as you can see, there's so many things and very fun things to do in the local universe. It's like in any other time of the universe. So let's see what other new discoveries lay ahead. Thank you.
Thank you very much, Anna. I'm going to start sharing my screen then. How to do it? Here it is. Perfect. Did you see it?
Yeah.
Perfect. So, for the starters, let me encourage all of you also to participate in the discussion, both in the chat and also in the Slack tool. And of course, be with us, because as you can see in the previous presentations, we have placed together many very interesting words in very few words. So apologies about that. I'm going to start reviewing cosmology and high redshift universe. I will start with the contribution by Sanchez Vázquez and collaborators and Oñorbe and collaborators, introducing the Calar Alto tetra-arm super IFU spectrograph survey. You can see in the left-hand side the huge field of view of this spectrograph, 3 × 3 arc minutes, observing between 320 and 760 nanometers. And they will perform a survey of 20 galaxy clusters and filaments at redshift 0.15, with also a wealth of data at high redshift that is going to be related with Lyman alpha emitters. On the bottom, Crespo Gomez and collaborators have carried out a symphony study in the H and K bands of a local sample of 10 luminous infrared galaxies, which are analogs to start forming high redshift galaxies. And there you can see the comparison between gas and stellar kinematics. On the low surface brightness realm, you have the work by Infanteside and collaborators, where they were able to describe the SDSS point spread function up to 8 arc minutes. And there you can see how well they are able to remove the point sources in the coma cluster. Similarly, Baena Galle and collaborators have done in both the Subaru Hypersupreme Cam data and SDSS Stripe 82. And also in the bottom left, work by me and Nacho Trujillo about the distruncations, the evolution of distruncations up to redshift 1, following the steps of the previous work shown by Anna, by Chamba and collaborators. Now on stellar populations, Díaz García and collaborators with exploration of the stellar contents of galaxies up to redshift 1, using the mini J-pass data and with the MAFIT code. On the right, Salvador Rusiñol and collaborators determining the amount of young stellar populations in massive early type galaxies. First, by doing a stack spectra of SDSS early type galaxies at redshift 0.4, and also a dedicated X-shooter study, also stacking the spectra of 6 brighter cluster galaxies at redshift 0.05. On the bottom, Garcia, Gumanes, and collaborators telling us that by performing 2D fitting to photometry instead of more traditional integrated photometry techniques, they are able to better reproduce the star formation histories of illustrious simulated galaxies. On the here on the left, Constantine and collaborators performing spectrophotometric batch disk decompositions in shards data for 100 massive galaxies at redshift below 1. Sotillo, Ramos, and collaborators in the Gamma survey, they are looking for the interplay between mass metallicity and star formation rate for over 700 galaxies that are residing in galaxy groups. Also speaking of overdensities, in the bottom, Castellanos and collaborators studying extended ionized gas in galaxy clusters because they say, they claim that these structures are the smoking gun of interactions among the galaxies in these galaxy overdensities. Then Supernovae science, 2 contributions led by Luis Galvani. The first one on the top, the Shiraz surveys, which are going to be HST wide field camera 3 observations of 24 Hubble flow type 1A supernovae. And also in the bottom, the very successful amusing survey, which has been running in VLT Muse for 10 semesters, and they were able to follow almost 800 supernovae during these years, and they will have the first data release later this year. Cabello and collaborators also displaying the first results on the Goya survey, which are going to be for low mass star forming galaxies between redshift 0.7 and 1.5 using EMIR at GTC multi-object spectroscopy mode. Also on the right, Navarro, Martinez, and collaborators determining the luminosity function of H-beta emitters at redshift 0.87 in the Otello survey with special attention to low luminosity objects. Lumbreras Calle also determining the properties and the luminosity function for all 3 emission line galaxies between redshift 0.4 and 0.8 in the Shard survey. González Otero forming Osiris at GTC spectroscopic survey of the Lockman Hall field for a total of 240 hours. And then also in these high redshift surveys, we have Rodriguez Espinosa and collaborators reporting observations of a protocluster of Lyman alpha detected galaxies at redshift 6.5. And also Cabello and collaborators on the left with near infrared narrow band, only 11 nanometers full width maximum imaging using Circe at GTC, looking for Lyman alpha emitters at redshift 9.3. Now going to the far infrared, we have the work by Coeli and collaborators placing observational constraint for the first time on the halo mass function by exploiting the magnification bias of submitter galaxies in the far infrared with also foreground galaxies. And using the same data, Bonavera and collaborators are also able to retrieve cosmological parameters, the value of cosmological parameters. In the bottom, another work by González Nuevo and Laura Bonavera as well on increasing by a factor of 5 the number of galaxy strong lengths in events in the H-Atlas dataset. And also from the same group, another contribution on the point source detection using fully convolutional networks in Planck simulations that apparently they also outperform previous methods. And also in all these machine learning techniques, we have Sarmiento reporting galaxy morphology classification using unsupervised, this time unsupervised machine learning techniques. And finally, cosmology, the dark energy survey, Mena Fernandez showing the first results on the barioacoustic oscillation on the dark energy survey GR3 data. Not really the GR3 data because this is so far screened, so they are showing us the results for 1,000 simulations, how well they are able to retrieve these values. And also Rodriguez Monroy and collaborators on the 2-point correlation function to determine galaxy clustering for simulations as well, and placing a special emphasis on mitigating the systematic errors induced by the observing conditions. In the bottom, Guidi and collaborators showing us full Northern Hemisphere maps of the Quixote CMB experiment at 11, 13, 17, and 19 gigahertz. And my final slide, Teo Lucena and collaborators applying Bayesian inference to gravitational wave detections in order to determine the characteristic of the sources. And here focusing in this very event. Also De Vicente, which has already used the SLAG tool, thank you very much. Also proposing a new relationship between the luminosity distance and the angular distance. And finally, Azori and collaborators, which they perform simulations, neutral hydrogen simulations of future surveys, focusing especially in the TN Light Pathfinder, and they are showing the effect of the survey noise levels and the beam sizes on recovering cosmological parameters. And in principle, this is everything. And now we are open to all your questions, remarks, etc.
Okay, thank you, Fernando.
So in the chat, I cannot see anything, neither in Slack.
No, I just see like some couple of questions, but they were from the beginning.
Let me unmute her.
Exactly.
Again, we all apologize for the little time we can invest in every contribution, but you can see that there were many, many things to cover.
Okay.
So please bear with us.
We have Cristina Ramos. Cristina Ramos has raised a hand, so you can talk,
Hello.
Cristina. Hola.
Hi, can you hear me?
Yes.
Hello. Thanks for the summary. It must have been hard to do. I just have a comment, a very general comment, that so I'm sure the way you divided the three topics was just to have more or less the same number, no, of contributions for each.
Yeah, more or less.
So, but I would like to point out that AGN these days are, I mean, they are interesting by themselves, but we are not kind of an isolated topic of study within extragalactic studies, because we are now more interested in the role that the AGN has in galaxy evolution than in the AGNs themselves. And actually, in some of Anna's talks, no, there were AGN related studies.
Absolutely. Yeah, I can take the blame on that. But when I was like, because in the local universe only like galaxy ones, there were already so many that was already like the main block. So then it was a little bit of separation, but absolutely true. And I mean, at the end of the day, everything is correlated, no? And yeah, we need to understand all of it together, not just one part over here and the AGN over there. But also we had a lot of talks on AGN stuff. So I think they also deserve, you know, like a proper subsection for themselves too. So
yeah, thank you.
Highlights the importance of the topic. It's on its own.
Okay.
Thank you.
We have now Isabel Marquez. Can you hear us?
Yeah.
Vale. Go ahead.
I'll put my video just for you to see how well dressed I am for the occasion. I'm at home. I'm sorry. So I'd like to congratulate you all for the organization. I mean, for the wrap up of all that you've done. I think it could have been differently, but it's wonderful, the work you've done. Just for next time that probably we'll have to face in the near future, I'm afraid. It'll be fine to put a picture of the people, of the PI of a project each time, because it somewhat replaces what we are expecting for a conference like this, in which the Spanish community is sharing ideas and sharing the knowledge of young people mostly. So so just an idea for if it can be, I mean, put in place from here to the last day, if you consider that a good idea. But again, just to congratulate you all and thank you very much.
No, thank you for the comment. I actually think it's a good idea. That's something, I guess, it should be done from the beginning. So when we ask for the contributions, then we should have asked for people to include that. But I do think it's an excellent idea for the future. And I do think so that we won't be able to see each other for a long time. So, yeah.
Well, Anna did do some statistics on gender, at least. So we saw that 40% contribution, female contribution, but of course we didn't put pictures, or that's the only study we could do with the available time we had.
And I also have to say that I did it only based on names, so I cannot claim, I mean, if there are, you know, other people that prefer to be called by different gender, obviously that doesn't reflect in there. So that's why we didn't really put it on the slides, but yeah.
Sorry for interrupting for a moment. We have a comment in the chat by Ana Esteban telling that her talk was not included in our slides. So Anna, we will look into that, but could you please comment just several phrases about what you did, please? I'm gonna look for you in order to give you some voice.
What? Okay, I'm gonna look at it right now because
it's an oversight.
Sorry.
Purpose for sure.
Anna, you have the mic if you want to say something about your contribution.
Don't worry. Don't worry. It's a huge work. I mean, it's a huge effort of summarizing everything. Can you hear me?
Yep.
Okay, thank you. I mean, it doesn't matter, no? I really enjoy the summaries. Just briefly, well, the talk is updated there in the webpage, so everyone can take a look if they want. But just in principle, we make we studied the population, the possible abundances of primordial black holes within stellar populations of thank you, of lens galaxies. Okay, it's a work we made together Evencio, which is also part of the IAC and collaborators. And yes, based on a previous study.
Anna,
yes, I mean,
summarize it very quickly because we cannot give you more time than all the rest of the people.
Yes, but based on LIGO measurements, no, of the possibility of having primordial massive black holes, no, with no spin or almost no spin and massive intermediate masses. We study the possibility of having these primordial massive black holes in lens galaxy systems, and that's it. This is the summary. And if anyone can take a look, you want.
What happened is that we actually moved this one from a couple of where to put it, and I think it got lost in those translations. Yeah, sorry. But there you go. You got a little bit extra way to show it now. Okay.
Apart from that, we have 5 extra minutes. Is there any topic that you would like to emphasize? For example, in my very case, I like it very much, the new Tarsis spectrograph in the Calar Alto Observatory. That was something completely unexpected for me. And I think that I don't know a lot of details about what you are gonna do, guys, but the fact of having such big field of view, also with observing in the blue part of the spectrum, could really outperform Muse or Blue Muse or at least come earlier than those, that at least the Blue Muse instrument. So it's gonna be very interesting, all the science that you can do.
Thank you. Yes, I think so, because we start very, at very short wavelength, so we can start 11 alpha at races much lower than Blue Muse. So that will allow us to, do some science on the physics of the Lima line better than, for example, Blue Muse, well, other things. We'll see. I mean, we passed to the second phase, and we now have to do the viability study and everything. But it's not. I mean, it's not for sure that it's going to be made, no. Yeah.
But if it's in the telescope, when more or less will be there?
Armando, are you over there? I think 2025. 2025,
perfectly fine.
Armando maybe knows better.
Well, but approx.
Marisa speaking.
Marisa. Marisa knows much better. Yeah.
Please,
Hi.
Marisa.
Marisa Vargas, yes. Well, the plan is to do in 3-4 years from the moment in which we have the funding. So in principle, we should be there in 2024. That's the plan.
Also, another thing I would like to comment is that I can see many attendees here, but there were not that many contributions, if I remember correctly, as those that we have in the previous SEA meeting. I guess that you didn't do it because it is not the same repercussion of your work as if you present it personally, okay? But yes, I see the contribution that's for several people missing here. So this is just a quick summary of the state of the art of the Spanish, let's say, Galaxy stuff. But I think that the picture is broader than what we show. But I was happy, at least in my mini session, to see contributions by small universities. For example, the Oviedo group was very visible here, and this is very nice. Another thing by Seska, which is, would like to ask, Seska says that whether we as a community would like to repeat this kind of meetings, but with more specific topics in a 3-month basis or something like that. What would be your thoughts about it?
I guess that's maybe better to ask in a survey or something.
Well, you can always, but you can always express your opinion in Slack, for example.
Yeah, for example. Yes, please, people, use it because it's a very powerful tool. I see that there's some people that post over there too. Slack usually stays there for a long time, so then you can always go back and check papers or discussions that you had.
Also, Isabel wants to say something. I am trying to give you the audio now. Yes, you have it.
Okay. So just to answer Cheska's question, I think it's a very good idea to try to take profit of the opportunity that viruses in general, I mean, the life that we have as today have provided us in these days of making profit of these kind of connection, of virtual connection, in order not to, not to leave the occasion of meeting up to making online, live face-to-face meetings. And I think it's a very good idea to try to enhance the network, the Spanish network, just with that kind of, if I have correctly understood, of well-focused meetings, so much smaller, I guess, in number of people, in which one of the possible things that we can get from is just enhancing much more Spanish networks and collaborations within Spain. So I think it's a good idea that it should be fine to try to put in place.
Also, we are almost over time, but there are 2 people that want to say something, I hope very quick. One is Santi Roca and the other is Ruben García Benito.
Well, I am sorry, probably it's not a very short question. It's basically a comment just for you to think on it and maybe to have some debate in the future. Is regarding the Milky Way. I think the Milky Way should be inside of this cosmology and galaxies. It's a long debate, an old debate. We have debated this a lot before, but I think now it's more and more interesting, this debate, and it has more sense now to have the Milky Way as a galaxy inside of cosmology and galaxies. Or maybe we have to make new divisions, not these parallelizations, because the Milky Way now behaves exactly the same as the galaxies, the external galaxies.
Fine.
Sorry, just a comment.
It's already very
and it makes sense. It goes again with Christina's comment. I mean, obviously, where to put these differences is really hard. And in particular, I mean, but by itself, it has so much work on it that, I mean, how do you pick which are the contributions, for example, that would fit from the Milky Way in here? So it earns by itself, but it's true that we tend to forget that it's there, no? It's totally true.
Just a very quick answer. Maybe it has more sense to have the Milky Way structure and formation inside galaxies and cosmology than heavy-halo objects and white dwarfs and structure and the halo streams. So I think we should make a new division, but well, we have to discuss it probably for the next year.
Well, for the La Laguna meeting, we were already discussing splitting cosmology and galaxies because, I mean, the topic is so broad. It's like all astrophysics, more or less. So already making their division, but now you want to add things. It's clear that it's something that the scientific committee has to address for next year, of how to better split things.
And also, I would like to hear very, very quickly from Robert Garcia Benito about the GAMACA instrument.
Yeah, thank you very much, Fernando. Yeah, as you know, there were a few projects for new instrumentation for Calar Alto. And finally, 2 of them were selected to carry out the feasibility study. One of those was Tarsis and the other GAMACA. So those are 2 IFUs proposed for the 3.5 meters. And in the following months, we will carry the feasibility study, and then the committee will decide between these 2 IFU answers.
But could you tell us just 2 phrases about GAMACA, please?
Yeah, GAMACA. So it's high resolution spectrograph. For now, is 1 arc-minute, okay, but it's like close to 4,000 spectral resolution, okay. And let's say the particular thing about this is that the fibers are thought to be 1 arc-minute, okay. Sorry, 1 arc-second. So the spatial resolution is very high. That's it because one of the projects is to get all the RGB stars in M31. So this is a very detailed study for very high resolution, spatial resolution studies, and also for nearby galaxies, okay? So it's high resolution, spatial resolution, and high spectral resolution for this. And hopefully we will develop more in the feasibility study.
Thank you, Ruben. I think that we should call it a session.
Thank you guys for all the effort.
Thank you very much to you for attending.
Yes, in these difficult times, it was not easy to contribute. To thank everybody.
Yeah, you've done great.
Goodbye, everyone. See you around. Ciao, ciao.
Bye.
Bye.